Hello, welcome to Young Minds versus Physics. So, in the last video, we abruptly stopped at Lami's theorem, right? So, we are continuing with the same. Right? If three vectors act at a point and the resultant is zero, that means if three forces acting on a body keep the body at equilibrium. So whenever the word equilibrium comes, it means that the resultant, because of all the vectors, is zero. Right? Then we are going to apply Lami's theorem here. So, and here, when you represent it in a triangle, right? All the three vectors are taken in order, right? Along the three sides of the triangle. Right, suppose if this is angle 1, this is 2, this is 3, that's opposite to A is 1, opposite to B bar is 2, opposite to C bar is 3. Now here we can just solve this one like if it is so. Right, now what about the angles between the vectors? See, 1 is not the angle between B bar and C bar. Why? Because extend B bar and angle between their directions is the angle between the two vectors. So therefore alpha, this exterior angle, is the angle between B bar and C bar. So which is opposite to A bar. An angle between B bar and A bar is gamma. Right? Angle between A bar and B bar is A bar and C bar. This is C bar is beta. Right? This can be represented like this. Right? Three vectors A bar, B bar and C bar are acting on a body and the body is at equilibrium. Then angle between B bar and C bar is alpha. Between A bar and C bar is beta. Between A bar and B bar is gamma, as what we have seen here. Between A bar and B bar it is gamma. Here also A bar and B bar it is gamma. Right? Just to remember, opposite to A bar, alpha. Opposite to B bar, beta. Opposite to C bar, it is gamma. So then Lami's theorem states that A by sine alpha is equal to B by sine beta is equal to C by sine gamma whenever three vectors acting on a body or acting at a point results in zero resultant, or three forces acting on a body keep the body at equilibrium, then we can use Lami's theorem. Now move on to this video's main topic, concept applications of components of vectors. So one by one, let us see the problems and see how to solve and how to think the way of solving it, right? A man rows a boat with a speed of 18 kilometer per hour in the northwest direction. So let's draw the directions now. This is east, west, north, south. Now a man rows a boat in northwest direction. That means with respect to the geographical directions we are talking about this. The shoreline makes an angle of 15 degrees south of west. Where is the shore of the water body? So this is the shore of the water body. Why? Because why am I drawing it here? Because he said in the problem it is given that making an angle of 15 degrees south of west. First take west. Is it along the west or along the north of west? No, it is south of west. That means you have to move southward by how much? 15 degrees. So this is the shoreline. Right? This is the shores. Seashore. Maybe. Right? Now the boat is rowed like this. Here two are given as a reference to us. One is the geographical direction of the boat is given. Next one is the shoreline, how at what angle it is with respect to the geographical directions, that is also given. So these two are important for us now. Now obtain the components of the velocity of the boat along the shoreline and perpendicular to shoreline. Now, though it is very much clear, we know this is the direction of the boat, this is the shoreline. Finished. Now, he is telling us, like, or the problem is, if 18 km per hour is the velocity of the boat in this direction, resolve this velocity into two components, one along the shoreline. Obviously, other will be the rectangular component of it, right? So where is that? So this is making 90 degrees with this, right? Perpendicular to shoreline will be the obviously other component, right? So therefore, now perpendicular means here it is. It may lie like this, right? 90 degrees with shoreline. With shoreline, this is 90. Don't ever get confused with the perpendicular to north, because in the diagram though you feel as if this is the shoreline and this is the other component. No, other component absolutely acts yet 90 degrees with this, right? So this is the perpendicular component. So now along this, what will be the component? Now for this we should know the angle between the shoreline and the velocity of the boat. Velocity of the boat 18 km per hour is a magnitude which is at 45 with west, and the shoreline is with 15 southward west. That means 15 plus 45. What is the total angle here? 60 degrees. So very easy. Now V cos 60 acts here. Now V sin 60 acts here. Finished. Problem is done. Right. So component along. So component along shoreline is, right, V cos 60. Yes. What is V? 18 km per hour into cos 60 is 1 by 2. So this is 9 kmph. And now perpendicular to shoreline. So the component is V sin 60, which is equal to V into sin 60 is root 3 by 2. So 9 root 3 kilometer per hour. Okay. So this is first, where is the life of the problem? It is with the diagram. The more clearly you can draw the diagram here, understanding step by step whatever is given, then you are almost done. Only thing is just to put the values and find the final result. But all this is the concept. This is the concept behind solving the problem. So you must be very careful about it. Okay? So pause and please note down. Yes, now second one. A vector is inclined at theta to the horizontal. Okay? And its vertical component is given to be y. So, okay, let me draw a vector. Okay? This is my vector. And this is making an angle of theta with the horizontal. Yes. With the horizontal line, it is making an angle y. An angle theta. Now, what else is given? And its vertical component is, this vector's vertical component is, right? So, which is along y-axis vertical component here. This is along x-axis. This is y. then magnitude of that vector is, what is the magnitude of, let us suppose that is the r, the resultant of these two components can be r, or the resolving vector r, right? So what is the magnitude of r, as well as what is the horizontal component. See, if only horizontal component is asked, how to do the problem is one case, and like suppose if r is asked, how to do it. Very simple. Now this is rx and this is ry. You know that ry is equal to r sine theta. So what is r is equal to? Ry by sine theta. What is ry? Ry is y. So therefore r is equal to y by sine theta, which is y cosecant theta. Depending on how the options are given, you can write it down. And now coming to rx. Right? So what is rx is equal to? R cos theta. So what is r? Y by sine theta into, so y cot theta. Y cot theta. So this is rx, that is the horizontal component is y cot theta. Magnitude of the actual given vector is r, which is equal to y cosecant theta. Magnitude of the given one is r, where vertical component is y. So y cosecant theta. Suppose if this is not asked, only directly horizontal component is asked, only this is asked, and theta is given to you. Okay, so now how to solve that? That means very quickly doing it. Rx is equal to r cos theta, ry is equal to r sin theta. Okay, so rx by y is equal to cot theta. Finished. Rx is equal to y cot theta. So these are the things which usually different people will be getting different ideas in solving it. Suppose if it is only horizontal component is asked, directly you can do this. Okay, when both are asked, that is the actual vector and the horizontal component, you can follow this method. Okay, pause and note down. This is very, very important, children. I am going to do this in two methods. Why am I going to do it in two methods is because in your advanced, right, the questions may come as though like multiple options might be correct. That means more than one option is right. So under such conditions, if the problem is asked how to do that, that one I am going to see here, show that. A car travels 6 kilometers towards north at an angle of 45 to the east. See, hold on. So my dear young minds, he didn't say only towards north. He said towards north, yet an angle of 45 to the east. That means it is moving in the northeast direction. So let me draw east, west, north, south. This is the direction of movement of the car. And this moved by 6 kilometers. Right. Now, and then travels a distance of 4 kilometers towards north, yet an angle of 135 degrees to the east. Again, it is moving in the direction of north only, making an angle of 135 degrees with east. Right. See, suppose if I draw at this point, after 6 kilometers, draw a line parallel to east. Now, it should make 135 degrees like this. That means this is the direction in which it is supposed to move. Right, that one I am drawing it here. Okay, that one I am drawing it here. Parallel shift. Parallel shift. You have to keep this one also in mind as well as this, because I'm going to do with the both methods. If I take it here, how am I going to do it here? And if I take it here, how am I going to do? That is very, very important, right? So now, how far is the point from the starting point? Now, after moving a distance of 4 kilometers in this direction, 6 kilometers in this direction, where is the final position? Right? How far is it from the starting position? And now, how much angle does it make with east? This is the question. Okay, so I will draw this splitting it into two kinds, right? So now let me first take this as, right, east, of course, said as x, west minus x, north we take as y, south as minus y. So now the first condition here is 6 kilometers. In which direction? Making an angle 45 degrees with the east, it is moving in the north direction. That means it is in northeast direction. The other one, this part I am going to take now. Right? So, and what is the other vector which is acting on the same car? So, I will draw it here. It can be drawn like that, right? So, making an angle of 135 degrees with east. Means already 90 is here. Now it is a 45. Is it not? 90 plus 45. Together it is 135. Now see how the two vectors are. This is one vector. This is another vector. I can resolve this vector into components. How? 6 cos 45. What is cos 45? 1 by root 2. So here I have, like for the first one, I'll take the first one as V1 bar, which is equal to 6 cos 45, 6 sin 45. So 1 by root 2. This is along I, so I'll write it as I cap, plus 6, 1 by root 2. Along y axis, so I'll write it as j cap. So 3 root 2 I cap plus 3 root 2 j cap. Are you all able to follow this one? Yes, I am resolving this, right? In xy coordinate plane, like taking this as position vector form. So xi cap plus yj cap. What is my x? As I already said, it is ax, which is a cos theta, a cos 60. Then ay, cos 45, a sin 45. So I got 3 root 2 I cap plus 3 root 2 j cap. This is my V1 bar. So that means one of the vectors which is acting on the car is known to us. Now let's go with V2 bar. Now suppose if this is V2. Let me resolve this now. Again 45, 45, and this is of 4 kilometers. So I can just find it as 4 cos 45, that is 1 by root 2. Right, along negative x-axis. So what is that? Minus I cap, minus I cap. So this is minus I cap. Now plus 4 into 1 by root 2 j cap. Right? So 4 sin 45 along positive y-axis. Right? So therefore this is the condition. Now you have minus 2 root 2 I cap plus 2 root 2 j cap. So this is your V2 bar. So I know these two. Now what do we need is resultant. That's all. V bar is equal to V1 bar plus V2 bar. Right. So this is 3 root 2 I cap minus 2 root 2 I cap. It is root 2 I cap plus 3 root 2 j cap plus 2 root 2 j cap 5 root 2 j cap. That means resultant is having a magnitude of root 2 in the x direction, positive, and 5 root 2 in y direction, that also positive. So resultant acts somewhere like this. Okay, so root 2 I cap, 5 root 2 j cap. So this is the vector form. This is the vector form. Now modulus of that, everybody can do that, not an issue. Root 2 square is 2, 5 root 2 square. So therefore 2 plus 25 into 2 under root. So that is root 52. So root 52 kmph. What is that? Kilometers. Root 52 kilometers is the distance from the initial point to the final point. Clear? So this is now knowing the direction. So angle made with x-axis. So that is tan alpha. Vy by vx. Vy by vx. That is y component by x component. So tan alpha is equal to 5 or alpha is equal to tan inverse of 5. This is the angle made by the car with east direction, that is with x direction. Right? I repeat the whole thing again. Look at this. So what is the question here? So a car is moving in the north direction, making an angle of 45 with the east, and it moved 6 kilometers. Fine. Correct. Now after that it is moving in 4 kilometers distance like this, making an angle 135. So I took the vector here. So 4 kilometers making an angle of 135. So what is happening here? This lies in the first quadrant. This lies in the second quadrant. So here it is making 45. I can resolve this into two components. So one component acts here, one acts here. And this can also be resolved into two components. One acts here and one acts here. And since it acts here, it is negative x-axis. So you'll get minus I cap. So both the components I wrote using the formula ax cos theta, a cos theta, a sin theta. A cos theta, a sin theta. Right. So the two vectors are ready now. The position vectors are ready. Now the resultant is v bar is equal to v1 bar plus v2 bar. So you got the x and the y components on adding these two. Right. So, and the magnitude is this, angle is this, vector form is this. Whichever, however the question is asked, whether it is asked in the vector form or to know the magnitude or direction. All the three are done for you. Now, somebody may prefer to do the problem like this. Let us see how it is. Like from the basic principles. So, east, north, west, south. So now first what is happening here? Car moved by 6 kilometers. And now from here, like if I draw a line parallel to east direction, that is positive x direction, it is making an angle of 135 degrees. 135 degrees with east. Then if this is 135 degrees and here you can see that the angle which it is making with this is 90 degrees. Okay, so now this is 4 kilometers. Now this is the initial point. Now this is the final point after the journey. So it is of course making some angle. Don't think that it is along north perfectly. Right. This is the resultant. Now from triangle of vectors or addition of vectors, whatever it is, the resultant R bar is equal to, right, this plus this, right? Right, 6 bar, that means the V1 bar plus V2 bar. So now both are at 90 degrees angle. So you have modulus of R bar is equal to 6 square plus 4 square, which is 36 plus 16, 52 under root. So easy, see? Very, very easy. The only thing here you have to do is that you should know what will be the angle over here. That means if you draw here parallel to x-axis and then draw parallel to y-axis, right, then you will be able to understand that it is 90 degrees here. Right, done. So root 52 kilometers is the resultant magnitude. Now what about the angle? What about the angle? So now here, now angle here with this one, right? So with this one you are going to find out the angle. So now tan alpha is equal to here, right? That is y by x again, right? So tan theta, I'll take it as tan theta is equal to y by x 4 by 6. With respect to 6 I am finding, because 6 is already with respect to e is at 45. So my job will become very easy here. This is already 45. So I am going to find this angle so that I can add these two and then find. Tan theta is equal to 4 by 6. So that is equal to 2 by 3, or theta is equal to tan inverse 2 by 3. So now angle made with E is, east direction is, right. So 45 plus theta. 45 plus theta, which is equal to 45 plus tan inverse of 2 by 3. This is one answer. This is another answer. So tan inverse of 5 is one answer for the angle, and for this one anyhow you got root 52 in both the cases. But here the values are same. So don't get confused. Value will be the same. If you use a logarithmic table and then see the natural tangents and all that, you will get the same value here. But your options may be of these two. So when more than one option is right, you must be able to identify this option also. Or else if you have done this, you must be able to identify this option also. So my dear young minds, this is very, very important for you people to note down, whoever are preparing for IIT mains, that is JEE main and JEE advanced. This is a very, very important problem. So pause for a moment and then note down. So I'll just try to show you clearly. So this is the actual problem given. I have done in two methods. One in position vector form, the other one in the basic basic triangular law of vectors, right? Triangle law of vectors. So is that clear? Yes. And for now, this is all. And let's wait for the next video to go with the other applications. See you again. Have a good day.